Hi, this is Anita from RMD Engineering College. Let's see about asynchronous counter. As the name indicates, asynchronous counter. Asynchronous meaning the clock pulse for each flip-flop is not parallelly given. The clock pulse of the next flip-flop depends from the previous flip-flop. The clock pulse of the next flip-flop depends on the previous flip-flop input. So that is the asynchronous. Then 4-bit up counter. 4-bit. The 4-bit states that there are 4 bits, that is from Q0, Q1, Q2, Q3. So where Q0 is the least significant bit. So as you see in the diagram, the Q0 is here, Q1, Q2, Q3. These outputs are taken from the Q. Outputs of each flip-flop. Actually, the flip-flop is a device which can store 1 bit. You can also see the clock pulses. For first flip-flop, the clock pulse is given externally. For the next flip-flop, this is the next flip-flop, for which the clock pulse is given from the previous flip-flop. Here we are using the D flip-flop for 4-bit up counter. So what is that up counter? Up counter means it starts counting from 0, 0, 0, 0 to 0, sorry, to 1, 1, 1, 1. So there are 4 bits which is used for counting 16. That is Q0, this is the Q0 value, Q1, Q2, Q3. So we are able to count from 00 to 1111. Again the counter will reach to 0, 0, 0, 0. Then it starts the counting again from 1, 1, 1, 1. So the cycle is repeated like this. So this is the up counter. So here we are using the D flip-flop. So here 4 flip-flops are used for storing 4 bits. 4-bit indicates 4 flip-flops should be used. So this is F0, F1, F2, F3. So the flip-flop f of 0 has the least significant bit Q0. So you can see that from the D flip-flop, the output is taken and it is connected to Q bar. For every clock pulse, the Q value the Q value is flipped. So we can see in the timing diagram how the flipping goes. Due to that flipping, the counting is carried out. So here we could see the clock pulses from 1 to 16, ranging from 1 to 16. So at the start of the clock pulse, you can see the bits Q0, Q1, Q2, Q3. So see the value. Here Q0 is 0, Q1 is 0, Q2 is 0, Q3 is 0. So at the edge triggering, this is actually flip-flop is a edge trigger. So at this point of triggering, you can see that the Q value is flipped from 0 to 1. So likewise, at this point of clock pulse edge of the clock pulse, there is a change of state of Q from 1 to 0. Again, for this point, it is 0 to 1. Likewise, the cycle is repeated, flipping of 1 to 0 or 0 to 1 occurs at the edge points. So next, seeing the Q1. The Q1 gets flipped at this end. So it is 0. At this edge point, it is flipped from here from 0 to 1. For the next edge, it is triggered from 1 to 0. Likewise, the cycle is repeated. At every occurrence of the edge point, here the changing of state of the Q occurs. Likewise, Q2. The Q2 depends on the previous Q1. So, at this point of Q1, there is a change in the state of Q2. Likewise, at this edge point, there is a change of value of the Q2. That is, it changes from 1 to 0. Again, at this edge point, you can see the changes. The Q3 most significant bit stays 0 till this point because it depends on the Q2. So at this occurrence, so here it changes its state from 0 to 1. So for the encountering the next edge point, it changes from 1 to 0. So if you see at this point, the value for Q0 is 1. Here it is 0. Here it is 0. Here it is 0. For the next point, it is 0, 1, 0, 0. 1, 1, 0, 0. So, seeing from the reverse manner, that is from Q3 to Q0. It is 0, 0, 0, 0, 0, which is 0. Next 0, 0, 0, 1, which is 1. 0, 0, 1, 0, which is 2. 0, 0, 1, 1, which is 3. Likewise, the counting goes on till 1, 1, 1, 1, which is the last state, 16. Thus, the counting of asynchronous counter is done by means of the flips in the flip-flops, state of flip-flops. by means of connecting the D to Q bar.